What is up, my brothers and sisters? So, on the way back home, go ahead and show you purple Nurple lights. Hold on. Hold on. Purple Nurple lights. Let's see. Here we go. Play it back for you. This is on the way back home. Sorry, the quality is not the best. But, this is a college campus right here. And, yeah, phone's not really doing it much justice, but it's all the lights turn purple. Okay. Let's see. See what we got going on. See, those are regular right there. So this is this morning. I've been meaning to try to catch this better, but seems to be on my ride to where I gotta go and back. See that light's purple. Purple. And that one's regular. Those are regular. There's several lights there that have turned purple. Okay. Well, see, purple. Purple Nurple. So, see, the one right there is regular, and then the ones right there are purple. Those are purple, and then that one's regular. Let's see if we can see that a little better. Regular lights. Let's try it beginning. Purple. Purple Nurple. Right, no, that one's purple. And those are the campuses over there. Those are regular. But then the other lights are purple. Okay. Nobody put those in. There's no conspiracy. Okay. But there is something happening. That light is regular. Okay. With that being said, let's get to the steak and potatoes. I've been hearing a noise outside when I feed Bandit and stuff like that and go mess around with them. And so I've been hearing the power lines. They're like, right? It says the hum you hear is usually twice the frequency of the AC power being used. A professor professes this in practice in the electrical and computer engineering department at Rice University in Texas. That means that in the US, electricity usually hums at 120 hertz, or between B and B flat, 2 octaves below the middle C. In Europe, it hums at 100 hertz, or between A flat and G, 2 octaves below the C. But what is exactly vibrating and creating that hum? It's usually a magnetic element inside the device. What device, you may ask yourself? When you're near power lines, you might hear an electric hum coming from an electromagnetic device called a transformer, which is used to decrease the voltage of power as it travels from the power plant to people's homes. So the high voltage from the power plant doesn't overload household. That way everything doesn't blow out in your house. A transformer has an inductor inside it, which is a magnetic element. It's an electromagnetic. It's electromagnetic. It's a piece of iron that has a coil of wire wrapped around it that's inside every transformer. We used to make tattoo guns like that. And basically what we would do is we would get like a screw. And we would get two Scrabble pieces, right? You put a hole in the Scrabble piece in the middle. And then you screw it all the way on until you get to the head of the screw. And then you put another one at the bottom of that screw. This is how ingenious and fine ingenuity a tattoo gun can be made with electricity and electromagnetism. So you get piece of Scrabble piece, and you screw it on all the way down the head, and then you get another Scrabble piece, and then you put it at the tip of that one. And then you get an electrical wire of some sorts, and you wrap it around, right? So then you have an end, and then you have a start, and then the wire is coiled around the screw itself. From there, you have to get like like an arm, a metal arm, because I call it floating, but it'll end up trying to pull that arm up and down. That's basically what like a tattoo gun is, right? So it's like an arm over the coil, and basically the magnetism of the electricity will hover that arm, and it'll basically pull it back and forth, plus negative, plus negative, plus negative, right? So for reasons of electrical engineering, you need to have an electromagnet inside of electronics to get that function that you want. This would also be like an alternator in your vehicle. Your battery isn't just powering up your electricity in the car or firing off your spark plugs. It is the alternator that is turning, and it is the coil itself, which is producing a magnetic property that keeps the electricity to even flow, right? So with that being said, you need to have an electromagnetic inside electronics. And so you can think of these magnetic elements as being like little magnets, and they're being energized by the electric power, right? Where am I? Okay. And so they're turning on and off, reversing their polarity. You have plus positive, plus positive, plus positive. It says 60 times a second, so they're actually vibrating a little bit. Yes, like a tattoo gun. The same thing happens in all sorts of electronics, from fluorescent bulbs to toaster ovens, right? Fluorescent bulbs. The reason power lines themselves might hum is due to a different phenomenon called corona discharge. This hum or discharge of energy happens when the electrical field around the power lines is greater than what is needed to start the flow of electrical current from the power line to the surrounding air. So for instance, the likelihood of that happening can depend on the weather, as water increases the conductivity of air. Most modern power lines are designed to avoid this problem, at least during dry conditions. If corona discharge does occur, it can be dangerous. Yeah, because you could get shocked, or like a arc of lightning bolt can come hit you and blow you the fuck up. It can be dangerous, and there's evidence that this discharge or hum, so basically it has to do with like the humidity in the air, right? So the discharge of this hum or discharge of energy happens when the electrical field around the power lines is greater than what is needed to start the flow of electrical current from the power line to the surrounding air. The likelihood of that happening can depend on the weather. As water increases the conductivity of air, it makes it electrical. You can feel the static. I mean, you're hearing the hum, right? Most modern power lines are designed to avoid this problem, at least in dry conditions. If corona discharge does occur, it can be dangerous. There's evidence that corona discharge can produce toxic gases like ozone, which can harm human lungs if inhaled. Can you believe that? Yeah, and you have it in your house, it's outside, it's all that good stuff, right? But is the mains hum in your electronics a sign of danger? Probably danger is too strong a word. The hum is usually just a normal part of how electronics function, but sometimes it can be a telltale sign that something is wrong. Well, you think? If it never hummed before and then suddenly starts to hum, it gets louder and louder. And that probably means that there's some element inside the device that is about to fail. The air conditioning unit in my home, one time it started making a 60 hertz hum, Wood said. So I called the air conditioner repairman, and they said, no, it's nothing. And I said, well, no, I know a 60 hertz hum when I hear it. There's something wrong. And so they came out, and sure enough, there was a bad component inside. Womp, womp. Well, let's see if we can test that out, because I've tested it several times. And let's see if I can go ahead and show you a fact. Let's go to the sound meter. Uh-oh. I guess it's not going to work. Ah! That's because I'm using the microphone. But it's okay. I'll give you an example.